Hi, sixth graders. This is a review for your quiz on Monday on the Earth, Moon, Sun, solar system. And this is all information that we've covered in class. So hopefully this is a review and you will be ready to show what you have been learning on Monday. So the first thing is the vocabulary that we've been using. So these are words that you should feel very comfortable with. Let's see if I can get my video to be out of there. Oh well. So rotation, revolution, axes, scale, astronomical unit, light year, and solar system. Those are words that are in quizzes, so you could go back to the review sheet in Canvas and click on the links to quizzes and you can practice them there. They are in your science notebook. I recommend making flashcards and testing yourself on them. Okay. Rotation is when an object spins on its axis, making a day. So the Earth spins once, which is our day, once a day on its axis. Revolution is when an object makes one trip around another object, which makes a year. Those two words are hard to keep track of sometimes. I remember that a year is longer than a day, at least on Earth. And the word revolution is longer than the word rotation. That's one way to remember which is which. Axis is the invisible line passing through a planet, and it's what that planet is spinning around, making its day. Scale is when you make something bigger or smaller, but you keep it proportional. And what that means is that you shrink everything the same way, or if you were making a larger scale model, you increase or make everything bigger in the same way. Astronomical unit is the distance from Earth to the Sun, and we use that for objects inside of our solar system. A light year is the distance that light travels in a year, and we use those for really big distances. So if you're talking about something outside of the solar system, an astronomer would use light years. And the solar system is the sun and all the objects that orbit around it, like planets, asteroids, moons, comets, dwarf planets. Okay, so you should recognize this diagram, and it's showing you how everything is moving in the Moon, Earth, Sun system. Of course, this is not to scale. Okay, remember there's 109 Earths across the sun. So on this diagram, what makes a day is when the Earth spins once. What makes a month is when the moon goes around the Earth once. What makes a year is when the Earth goes around the sun once. So that's showing you how everything's moving. All right, and here's some data. And I would never expect you to have this information memorized, but you ought to be able to look at a data table like this and answer some questions about the solar system. So understanding how to use a data table. For example, looking at this data table, what planet is 30 times farther from the sun than Earth? So you would look at the column called average distance from the sun and notice that Earth is 1 AU. That's the definition of an AU. So the planet that's 30 times further would be a planet that's about 30 AUs from the sun. And it looks like that would be Neptune. So Neptune is 30 times further from the sun than Earth. What planet is the closest to the sun? Mercury. It's 0.39, so it's less than the distance from Earth to the sun. And the planet that is, that's the planet that is closest to the sun. The planet that is closest to Earth, well, it would either be Venus on one side or Mars on the other. And it looks like it would be Venus, because the distance from Venus to Earth is about 20.25 or a quarter of an AU, whereas Mars is about a half of an AU further or away from Earth. Okay, so the planet that is closest to Earth would be Venus. Okay, we're going to look at the size of the planets, and that would be the last column, radius of a planet. In order to understand that, you need to know what a radius is. And if you look at the circle on the screen, radius is a mathematical term for the distance from the center of a circle to its edge. So in this situation, it's the center of the planet to the edge of the planet. Okay, so it says, which planet is the biggest? Well, by now we probably know Jupiter. Jupiter is 71,492 kilometers wide in terms of its radius. What planet is the smallest? Well, that would be Mercury, 2,440 kilometer radius. What two planets are the closest in size? Well, Venus and Earth are pretty close in size. So Venus is 6,051 kilometers, whereas Earth is 6,378 kilometer radius. And a lot of times when we're looking at scale models of the solar system, whoever's making that model will use the same item for both Venus and Earth because they're pretty close in size. What planet is about half the size of Earth? Well, Earth's radius is 6,378. So in terms of radius, Mars is about half of that. So 3,397 kilometers for its radius. So again, you guys, can you look at information from a data table and use it to answer some questions? Okay, the last questions would be about the orbital period, which is how long it takes a planet to go around the sun, which is also a year on that planet compared to Earth. So if you look at this table, Earth is one orbital period. So any number less than 1 means that the year is shorter than Earth, and any number over 1 for the orbital period means that the year on that planet is longer than an Earth year. So looking at the orbital periods from Mercury to Neptune, what pattern do you see? And remember, Mercury is closest to the sun and Neptune is the furthest. In other words, what is the relationship between a planet's distance from the sun and its length of year? So Mercury is 0.24 is how long, so it's about a quarter of the time for a year on Earth, whereas Neptune's year is 164 times the length of Earth's year. And that pattern, if you look at those numbers going from Mercury to Neptune for orbital periods, just keep getting bigger and bigger. Okay? So you can make a statement such as, the closer a planet is to the sun, the shorter its orbital period, or the shorter the year. Or a planet that's further from the sun, like Neptune, has the longest year. And then you would want to back that up with data. So Mercury, a year on Mercury is 0.24 Earth years, whereas a year on Neptune is 164 Earth years. And remember, we've talked about the fact that a day on the planets does not have that pattern. It's random. Okay, here's another question for you. And that picture, by the way, is to scale. So if you look at the sun, you can imagine that 109 of those Earths could fit across that huge sun. If you look at the moon, you can imagine that 4 of those moons would fit across Earth. Pretend you're making a scale model of the size of the planets. If you were using a 2-story house for the sun, what would be a reasonable object to use as Earth? Explain why you chose this object. Okay, so you need to be able to think about, well, what's an object that 109 of them would fit across the Earth? So a car or a shack is probably too big. Okay, I don't know, like a pin or a marble might be too small. Maybe a golf ball. I think we talked about a shoe. What would be something that would reasonably fit across a 2-story house 109 times? Okay, so it's hard to find a picture of the solar system that is to scale for both planet size and the distance between planets. That's because there is so much space between the planets that to put it all on a page or a poster, when you shrink the planets down enough to fit on that piece of paper or poster, the planets become too small to see. Okay, so can you evaluate a picture of the solar system and kind of see, well, what's accurate to scale and what isn't? So for example, in this picture, and we've seen this picture before, what would be accurate is the relative size of the planets and the sun. So they shrunk the size of the planets and the suns at the same rate. So even though everything's smaller, they're the right ratio. They've all been shrunk at the same amount. The order of the planets is accurate. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. What's not accurate about this model is the distance between the planets. In our solar system, the planets are not equally distanced apart like this. In fact, remember when we put the planets on a football field, which was a scale model for both distance and size, all of the inner planets, the rocky planets, Mercury, Venus, Earth, and Mars, they all fit on that football field. But then we had to go way off of the football field to put Jupiter, Saturn, Uranus, and Neptune, those outer gas planets. It's a big space between them. Another thing that is not realistic or accurate with this picture is that the planets will never be all lined up perfectly like that. So here's another picture, you guys. This model shows the distance between the planets to scale, but now the size of the planets are 1,000 times bigger than they would be if you shrunk it. So even though if you look at this picture, Pluto is so small, we know it's a dwarf planet, and let's see, Mercury, Venus, Earth, and Mars are so small on it. If they were going to be accurate for the size of these planets, they would be 1,000 times smaller than they are on this picture. However, this particular picture is showing the distances to scale. So you can see that those planets are not equally spread out. You can see there's a big gap between Uranus and Neptune and Saturn and Uranus. And then you can see that those inner rocky planets, the first 4, are kind of squished together. So this is a really different picture. It is showing the distances to scale, but not the size. And this one is showing the size to scale, but not the distance. Okay, so do we know what all we are talking about when we refer to our solar system? Our solar system consists of our star, the sun, and everything that's bound to it by gravity. So that would include the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, dwarf planets like Pluto, dozens of moons, and millions of asteroids, comets, and meteoroids. So things that would not be part of our solar system would be other galaxies. Even our galaxy is bigger than our actual solar system. Other stars, constellations, the universe, black holes. We don't have a black hole in our solar system. Supernovas and nebulae. So all of the that kind of gives you an idea of what we consider our solar system, and then what is outside of our solar system. Okay, you should be able to match an astronomical event, so that is something taking place out in space, to a unit of time that humans use. Okay, for example, the rotation of a planet or a spinning of a planet constitutes or makes a day. One trip or revolution of a planet around the sun is a year, and the one revolution of the moon around the earth makes our month. Remember, moon and month are similar words. Also remember that revolution is a longer word than rotation, and a year on earth is longer than a day on earth. Okay, so you guys, also inside of your Canvas review sheet, there are some videos you can watch. Practice that vocabulary. I would go through the slideshow a few times. All right, I'll see you on Monday.